Alright, for this question you have to find ABC. The end wall of a building has a shape illustrated, so that's just what the end of the wall looks like, where the centre of arc AB is at C. So as you can see, that's 30 metres. That is an equal length, so they should both be halves of 30 each. So 15 metres here and 15 metres here. So you need to find, first of all, A, alpha, to 4 significant figures. So alpha's over here, so that could probably just be used by the triangle. 5 metres, 15 metres, and I've got my alpha. So that should simply just be using trigonometric ratios, right? That's opposite of the angle, that's adjacent of the angle. So OA, so here is tan theta equals opposite over adjacent. So you go tan alpha equals opposite over adjacent. So if I want to find alpha, I just inverse the tan. Make sure your calculator is in degrees for this one. I get about 18.434. Just looking if I want to use 4 significant figures. I just want to make sure I look at the next one to figure out if I round up or down. So I go round down 18.43 degrees. And then my B would be finding the theta to 4 significant figures. As you can see, this angle is also alpha. This angle is what we're trying to find at the moment. So if I kind of redraw that, this is 180 degrees, right? It's a straight line. This one's 18.43 degrees, same as this one. So you should be able to find this angle, okay? Because they add up to 180. So I should be able to write an equation. So 2 lots of 18.43. So my theta should be 180 take 2 lots of 18.43. So I get 143.14 degrees. So let me just go double check those two answers. Just reminding myself that it's 4 significant figures, so that's 4 numbers. And let's do C. So the area of the wall. If I want to find the area of the wall, easiest way to do it is find the area of the sector, and then find the area of the triangles, and then add them all up together. So I'm going to do sector first. Okay, how to find the area of sector would be the fraction of 360 times pi r squared. So that would be theta was that theta 143.1, 360 degrees. My radius I don't actually know, so I'm going to quickly figure it out. I'm going to draw a triangle. So that's 5 meters, that's my right angle, that's my 15 meters, so I should be able to use Pythag to quickly figure it out. So x is square root of 5 squared plus 15 squared. So hopefully you've done, you know, it's so many times that it doesn't even faze you. So just a little bit of a tip, so it's square root of this, but as you can see it's squared of that, so they end up cancelling each other out, so I can kind of get rid of it and leave it like so. So if I just chuck that in the calculator, I get my exact value is 795 over 8 pi, approximately being 312.2 meters squared, and I just got to find the area of the triangle. I'm going to find the area of triangles. So equals, so I'm just going to, it's half times base times height, but I'm just going to get rid of that half by timesing it by 2 because it's 2 triangles, so these cancel out. So it's just going to be 15 times 5 because that's the base and the height. So 75 meters squared. So if I want to find the total area, I just add these two together. Three, 9.2 meters squared. Double check the answer. Did I add it wrong? Oh, I did. 387.2 meters squared, which is approximately the same answer.